Dear colleagues, let me welcome you. My name is Yury Gapanyuk. I am an Associate Professor of Computer Science and Control Systems Department in Bauman Moscow State Technical University. In this presentation, we will talk about the implementation of Metagraph agents based on functional reactive programming. Since the topic of the presentation is specific to the Metagraph model, first we need to say a little about the Metagraph model itself. Then we'll look at the principles of Metagraph against operation. And finally we consider an approach to the Metagraph against implementation based on functional reactive programming. Currently, models based on complex networks are increasingly used in various fields of science, from mathematics and computer science to biology and sociology. A complex network is a graph or network with non-trivial topological features. These features are often occur in graph modeling of real systems. The terms complex network and complex graph are often used synonymously. The term complex network or simply network usually refers to the real systems, while the term graph is generally considered as a mathematical representation of a network. In our work, we also acknowledge these terms synonymously. One of the most important types of such models is complex networks with emergence. The term emergence is used in general system theory. The emergent element means a whole that cannot be separated into its component parts. Nowadays, there are two complex networks with emergence models exist: hypernetworks and metagraphs. The hypernetwork model is major and it helps to understand many aspects of complex networks with an emergence. But the metagraph model is more flexible and convenient for use in information systems. A metagraph is a kind of complex network model proposed by Amit Basu and Robert Blanning in their book Metagraphs and their Applications. And then this model were adapted by the authors for information system description. The main parts of metagraph models are vertices and edges, as in ordinary plane graph, and also meta-vertices and meta-edges. The meta-vertex, in addition to the attributes, include a fragment of the metagraph. The presence of private attributes and connections for a meta-vertex is a distinguishing feature of a metagraph. It makes the definition of metagraph holonic. A meta-vertex may include a number of low-level elements and in turn may be included in a number of high-level elements. From the general system theory point of view, a meta-vertex is a special case of the manifestation of the emergence principle, which means that a meta-vertex with its private attributes and connections becomes a whole that cannot be separated into its component parts. The example of metagraph is given in current slide. We can see that meta-vertex may include inner vertices and connecting them edges. The edge may connect two vertices included in one meta-vertex. Edge may connect two vertices from different metavertices. Edge may connect vertex and metavertex, and edge may connect metavertex and another metavertex. And metavertex may include vertices, edges, and inner metavertices. Meta-edge may be considered as a path of metavertex. During transition to the destination vertex, the nested metagraph fragment became more complex, new vertices, edges, and metavertices are added, and thus meta-edge allow binding the stage of nested metagraph fragments development to the steps of process described with meta-edge. Thus, meta-edge is a special element of metagraph model proposed for process description. Now let's talk about the metagraph model processing. The metagraph data model is aimed for complex data and process description, but it is not aimed for data transformation. The idea for transforming the flat graphs with agents with multi-agent systems was proposed by Professor Vladimir Galenkov in his graphodynamics approach. By analogy with graphodynamics approach, the metagraph agent aimed for metagraph transformation is proposed. There are two kinds of metagraph agents: the metagraph function agent and the metagraph rule agent. The metagraph function agent serves as function with input and output parameter in form of metagraph. We can see metagraph as input parameter, metagraph as output parameter, and abstract syntax tree that may be represented in form of graph or metagraph. Thus, three components of function agent may be represented as a metagraph fragment. The metagraph rule agent is rule-based. The model of metagraph rule agent includes working metagraph, on the basis of which the rules of agent are performed, set of rules, start condition. The antecedent of rule is the condition or a metagraph fragment. The consequent of rule is the set of actions performed on working metagraph. Rules can be divided into open and closed. The consequent of open rule is not permitted to change a metagraph fragment occurring in rule antecedent. In this case, the input and output metagraph fragments may be separated. The open rule is similar to the template engine that generates the output metagraph based on the input metagraph. The consequent of closed rule is permitted to change metagraph fragment occurring in rule antecedent. The metagraph fragment changing in rule consequent cause to trigger the antecedents of other rules bound to the same metagraph fragment. Thus, metagraph rule agent can generate the output metagraph based on the input metagraph using open rules, or can modify the single metagraph using closed rules. The distinguishing feature of metagraph agent is its homoiconicity, which means that it can be data structure for itself. This is due to the fact that, according to the definition of metagraph agent, may be represented as a set of metagraph fragments, and this set can be combined in a single metagraph. Thus, metagraph agent can change the structure of other metagraph agents. The example of a homoiconic representation of Metagraph agent is given in current slide. In order to combine the data Metagraph model and Metagraph agent model, the concept of active Metagraph is proposed. The main difference between active Metagraph and a single Metagraph agent is that an active Metagraph contains a set of Metagraph agents that can use both closed and open rules, and these Metagraph agents are bound to the single data Metagraph fragment. For example, one agent may change the structure of active Metagraph using closed rules, while the other may send Metagraph data to another active Metagraph using open rules. Agents work independently and can be started and stopped without affecting each other. Now let's talk about the Metagraph agents implementation using functional reactive programming. Let's recall that functional reactive programming is based on two main ideas: behavior and event. Behaviors are mutable states that could be changed by some handling functions, which are called by events. Behaviors and events could be identified as data types with corresponding functions. Here we use implementation in Haskell programming language. In functional reactive programming, behavior and event types carry a collection of several combinators to represent at some categorical elements. Behaviors could lift functions into themselves for it to be applied. Using Haskell implementation, we may describe a Metagraph agent as a complex type of behaviors that contains vertices and edges of a Metagraph. In this implementation, on its upper layer, the Metagraph is a union of vertices, edges, metavertices, and meta-edges. Implementing the Metagraph vertex, we may use the fact that Haskell language allows us to use optional types. Thus, we can combine the implementation of the vertex and metavertex into a single whole type using maybe or optional type. The implementation of the edge corresponds to the definition of the edge and meta-edge. The direction and attribute fields describe the corresponding representation in the Metagraph. Thus, we also get a variable structure that can change its type from edge to meta-edge and vice versa, depending on external or internal events. The final agent type will look as follows, based on agent and rules definitions. Thus, the proposed Metagraph agent implementation gives an opportunity to rebuild its structure during the execution. All elements of agents are behaviors, so they are mutable functions of time and external events that produce both internal elements of the agent and other agents or the system itself. Thus, events in that approach could be used directly as agent messages. They can carry agents and agents subgraphs or any other type if required. Implementation of agents seems to provide a kind of homoiconicity, as the agent could change their actions and structure using functional reactive programming mechanisms such as behaviors and events. In conclusion, the following considerations can be drawn. The Metagraph model is a kind of complex network model with the emergence. For the Metagraph model processing, the Metagraph function agent and Metagraph rule agent can be used. The Metagraph agent may be implemented based on functional reactive programming paradigm using the Haskell programming language. The last slide provides a list of papers references. This is the end of our presentation. Thank you for your attention. Here is my email address. Please contact me if you have any questions.